In this video, we're going to look at the volume of pyramids and cones. So the reason we do pyramids and cones together is because they only have one base, whereas prisms and cylinders have two bases. So your formula to find the volume of a pyramid is 1/3 capital B times H. So the capital B stands for the area of the base. So that can change depending on what your base shape is, whether it's a triangle, a square, a trapezoid, a hexagon, pentagon, doesn't look like one, a hexagon or a pentagon, hexagon, as long as they are regular hexagons. So it depends on what those shapes are for your base area. And then H is your height. So that's the straight up and down distance perpendicular to the base. It is not your slant height, because we were dealing with slant height with surface area. This is just your regular height. So let's look at an example of finding the volume of this pyramid. So this would be a square pyramid, which means our base is a square. So our volume formula is 1/3 capital B times H. So 1/3. Our base area would be 2 times 2, because it's a square, base times height. And then the height of the whole cone, pyramid, would be 3. So our volume for this pyramid would be 4 yards cubed. So your volume formula for a cone is very similar. It's still 1/3 capital B times H. But in this case, your cone is always going to have a circular base. So it's always going to be 1/3 pi r squared, because that's how you find the area of your circle base, times the height. So really, if you had a cylinder that was the same exact height and radius as a cone, it would take 3 of the cones to fill up your cylinder, because it is 1/3 of the volume of a cylinder. So let's look at an example. So our volume formula, 1/3 pi r squared times the height. 1/3 pi, the radius would be 3 squared, making sure that we take half that radius, and then the height is 7. So we'll get the volume to equal 21 pi yards cubed. Just keep in mind that if you have the slant height given, then you would have to use the Pythagorean theorem to find your regular height. Obviously, that's not the case in this picture, but it can happen. So let's look at another example. So it's going to involve a little bit more manipulation. So in this cone, we don't have the height or the radius. We're going to have to use some right triangles to find it. As we remember from learning about circles, an inscribed angle that comes from a semicircle, since the semicircle is 180, the inscribed angle is always going to be half of that, or 90. So I have a right angle back there. So that gives me a right triangle to work with. And it's a right triangle that has 2 sides, 7 and 10. So I can use the Pythagorean theorem to find that third side. So I get that third side to be 12.2, which means that the radius is going to be 6.1. So I have the radius, but now we also need the height. So I have a right triangle in this picture, another one, a different one, where this side, since I just found the radius, is 6.1, and we're looking for the height. So we're looking for that part of it. So I can use trig, or it also happens to be a 30, 60, 90 if you would like to use 30, 60, 90, but if not, that's okay. So this is my index angle. This is your opposite side. This is the hypotenuse, and then this one is our adjacent. So I have O, and I'm looking for A, so that's going to be tangent. So tangent of 30 is going to equal our opposite, which was 6.1, over our adjacent, which was x. So x is going to equal 6.1 divided by the tangent of 30. So I get x to equal about 10.6. So that is my height. So I'm going to erase this so I can find the volume now, since I have the radius and the height, because those are the two measurements that I needed. Okay, so our volume formula is 1/3 pi r squared times the height. So 1/3 pi, the radius was 6.1 squared, and then the height was 10.6. So that's about 131.5 pi, or rounded to the nearest tenth, you could say that it is 413.0, and those are both in units cubed. So now going back to composite shapes, we looked at composite shapes when we did surface area, and they were a little bit more tricky because we had to consider what was exposed and what's not exposed. So we've done this shape before with surface area, but now let's look at volume. It's a lot easier because you're just going to take the two and add them together. You don't have to worry about what's exposed and what's not exposed. So I'll take the cone first, where our volume formula is 1/3 pi r squared times the height. So 1/3 pi, the radius of the cone is 9, and then the height is 12. So we get the volume for the cone to be 36 pi units cubed. So now let's look at the cylinder. Our volume formula for cylinder is pi r squared times the height. So pi times the radius of the cylinder is also 9 squared, and then the height of the cylinder is 64. So that's going to give us 5,184 pi units cubed. So our total is 36 pi plus 5,184 pi. So that's going to be 5,220 pi units cubed. Probably a lot easier than when we did surface area of these kinds of shapes. So now if you would like to try some problems on your own, I have some on here with the answers next to them so that you can check those answers. So there's ones here that are pyramids, and then we have cones, and then some composite shapes. So if you would like to try any of them, just pause the video on that page and then you can check your answers.